Alright, so let's jump into a question. It says a 258 milliliter sample of hydrogen was collected over water at 22 degrees Celsius on a day when the atmospheric pressure was 756 torr. And it tells us the vapor pressure of water under these conditions is 17.5 torr. What will be the dry hydrogen, no water vapor, will occupy at STP? So the first thing we do is in any one of these we write down our given. So our given that we have. We have our volume of 200, or our V1 of 258 milliliters. We have a T1 of our 22 degrees Celsius, which we go ahead and we take that and put it into Kelvin. So we add 273 to it, and we get a total of 295 Kelvin. And then we have our pressure. Now, what we have to look at is this pressure, that 756 torr. Since that hydrogen was collected over water, it has water vapor in it. So what we have to do is we have to subtract out the partial pressure of water vapor to get that dry gas. So what we use is we use the equation where we have our pressure of the dry gas, or in this case, we'll just call it our pressure of hydrogen, which will equal the total pressure minus the pressure of water vapor. So we get the pressure of hydrogen gas will equal the total pressure, which in that case is 756 torr, minus our 17.54, and we will get a pressure of our hydrogen gas, which in this case will be our P1, of 738.46 torr. Okay, so we have our V1, our T1, our P1. Now it says what volume will the gas occupy at STP. So our T2 is going to be 273 Kelvin. Our P2, since our P1 is in torr, we want to put P2 in torr as well, so that's just 760 torr. That's our given. Our unknown in this case is going to be what volume, so we're solving for our unknown is going to be our V2. Our equation that we're going to use, since nothing's held constant, we don't have our isobaric, isochoric, or isothermal conditions, we will use the equation P1 V1 all over T1 equals P2 V2 all over T2. Okay, substitute everything in for this. In this case, I like to solve for it, so what we'll get is we'll get our P1 V1 T2 equals P2 V2 T1. Okay, since we're solving for our V2, we go ahead and divide both sides by P2 T1. And we see that these guys will cancel out, and we're left with this equation. So subbing everything in, we get our P1, which is our 738.46 times our V1, which is our, and that is torr, our V1, which is our 258, and then our T2, which is 273. Running out of room, so didn't put the units there. And then we have our P2, which is 760, and then our T1, which is 295 Kelvin. We go ahead and plug all of this into a calculator, and we will get an answer of right around 0.2319, this one right there. Okay, the one thing we have to pay attention to here is that our original volume is in milliliters. So when I plug that into the calculator, I'll get milliliters, and I just need to divide by 1,000, and then I would get that exactly.